I'd like to take a couple minutes to show you a way to do this problem in your head, and it falls out from the algebra equation we set up here, so I'll show you how the two are really one and the same. Moreover, I want you to recognize, or hope you could see, that this is really a mixture problem. In this case, it's a group of students with average scores rather than the percentage of salt in a solution or the percentage of gold in a rock or some other typical mixture problem as you would see. But really the setup is a mixture problem, so this works for any mixture problems you get, and you might be familiar with those from your classwork. So here's how you might look at it in a slightly different way. As we solved before, we multiplied it out to start. 88 times 10 plus 88 times n, exactly as we did before. And then we moved like terms to like sides. So we collected the n's over on the left side, which became essentially 92n minus 88n, which really is 92 minus 88n on the left side. And on the right side, we took our 88 times 10, subtracting the 80 times 10 from the left side to eliminate it over there. Our expression on the right side became essentially 88 minus 80 times 10. Now let's pause for a moment to understand exactly what these numbers mean. The 92 minus the 88 really is the difference of group 2 scores from the average score. So group 2 was plus 4 relative to the average score. N was the number of students for group 2. It was our count for group 2, right? So count 2 of group 2 and difference from average. Likewise, over here, 88 minus 80 is the difference of group 1 average scores from the total average. And that was 88 minus 8, which is 8, times the count of students. 10 is really just the count of group 1, and 8 represents the difference from average for group 1. So this is really important. These two are essentially the same. The difference of group 2 from the average times the count of group 2 equals the difference of group 1 from the cumulative or total average times the count of group 1, which means we really just have a ratio problem. An even better way to think about it is visually, in terms of a scale or maybe a seesaw that needs to be balanced. If the length of one side of our seesaw is the difference from average for the second group, 92 minus 8, which we said before is 4, and the length of the other side of the seesaw is twice as long, the difference of the average from the first group, which we said before was 8, we know n, the amount of people we need to sit on the end of the left side of the seesaw, must be twice as much as 10, the amount of people sitting on the right side of the seesaw, in order for those figures to remain equal. Or you can see the ratio of 8 to 4 has to be offset by the ratio of n to 10. So if this is 2 to 1 from group 1 to group 2, then it must be 2 to 1 in terms of the count to offset it from group 2 back to group 1. That allows you to solve the problems more quickly. One other example that shows this, let's look at a mixture problem. For example, let's suppose I have 12% hydrochloric acid solution, and in total I have 10 milliliters. I want to mix that with water to get a 4% hydrochloric solution in total. How much water do I have to mix that with? Well, the problem is very similar. If 4 is the intended target and I have 12%, that means I want to reduce it by 8%. And water, we know, is 0% hydrochloric acid. There is no acid in the water. So 4 to 0 is 4% difference from average, and I know I'm starting with 10 milliliters of my hydrochloric solution, which is 8% away from my target mixture. So my weight over here is just going to be 10. And lo and behold, the numbers are exactly the same. We want to solve for how much water? N. N is going to be 8% times 10 over 4. Those will cancel. 20 milliliters. The problems are essentially the same, and you can eyeball them by noting the differences from average. So in this case, 12% is 8% difference from the target rate, and 0% water is 4% difference from the target rate. The amounts must be in inverse proportions to keep our seesaw nice and balanced. And to give you something further to noodle on, about 80 to 90% of your word problems will be either a mixture problem, a distance equals rate times time problem, or an average problem. And each of these is really, if you think about it mathematically, just the same, all of the form A equals B times C, which means the tricks you just learned you could probably use for any of these types of problems if you use them properly.